Swayam Prabha. Digital India. Educated India.
So today's topic is hypothesis testing. So first of all, we need to know what is hypothesis. Now we can face certain situations in which rather than estimating the value of a parameter, we try to decide whether a statement concerning a parameter is true or false. That is, our main concern is not about the value, but whether a statement that we make about a parameter, whether that statement is correct or wrong. This kind of situation arises. That means basically we need to test a hypothesis about a parameter. A statement that we make about a parameter is known as hypothesis. And whether that hypothesis is correct or wrong, we can also say whether it's true or false. That's what we want to test. Let us take an example. Let us say weight of finished garment from a previous experience is known to us, and the values are, the mean is 260 gram and the standard deviation is 8 gram. So some kind of finished garment is maybe a suppose t-shirt whose mean value weight is known and standard deviation is known to us. Now we make some process modifications. Something is changed in the process, and then we measure again what is the mean value of the garment weight that we are producing now. So suppose we get a value which is 263 gram, and this is based on how many tests? 40 tests. That is, we select randomly 40 garments and measure their weight, and we find that the mean value is now 263 gram. So this is the mean value of the sample. Now the question that comes to the mind is there a sufficient evidence to conclude that the finishing process reduced the weight? So, or the finishing process increased the weight, or the finishing process changed the weight? This kind of statement we can make, and we are interested to know whether at all there is a change or not. Now, how do we go about it? Now, if we ask this question, there are two possible answers. One is that the population mean has remained same at 260 gram, and the larger mean of 260 gram is just because of chance. Because we are not testing the entire populations, we are testing only a sample, and the size of the sample is only 40. That is, 40 pieces have been tested for weight, and the mean value is 263 gram. So this possibility is there, but there is no change, and the 263 gram values that we get is just because of chance. If we go for another sample and one more sample, we may find some values close to 260, or maybe slightly less than 260 also. The other possibility is the new process has really increased the mean. So these are the two possible answers. One, that it is really larger, or the mean has not changed at all. These two possibilities can be stated as hypothesis. The first, that the new process has no effect, is called null hypothesis, and it is denoted by H0. That's what we write, hypothesis O, which says mu is equal to mu O. That is, mu is equal to mu observed. They are same, there's no change. And the other one is the second possibility, the new process increase the mean, is called alternative hypothesis. And this one is denoted by H1. So this is the notation H0 and H1. And what H1 says, mu is not equal to mu. That is, they are not same. Whether it is more or less, that is not stated in this. So alternative hypothesis says that mean has not changed. The mean is not equal to original mean. The previous one says the mean has not changed. So that's same. The next one says no, there is a change. The present mean is not equal to the original mean. These are the differences between the null hypothesis and alternative hypothesis. Now the question that comes to mind, that how to know which hypothesis is true, that is, which statement is true. This is what we are interested to know. So we go to seek answer to these questions. So acceptance of null hypothesis. Null hypothesis, which basically means there's no change, is accepted until it is shown that the evidence against it available in the sample or from the sample that we take could not reasonably have occurred by chance. Then only we will accept the null hypothesis. And therefore we need to measure the probability of obtaining evidence. This reasonability has to be established by probability. So we need to measure the probability of obtaining evidence from the sample, but whatever samples that we collect, assuming that the null hypothesis is true. That is the assumption we make. Then if the probability that we find is high, then we say we don't have enough evidence to reject null hypothesis, and null hypothesis is accepted in this case. So probability of null hypothesis being true is high. The other is just opposite to that. The probability is low. In that case, the null hypothesis has to be rejected, and we go for accepting the alternative hypothesis. So we need to measure the probability of the evidence that we have. That is what we need to measure. But one thing is important to know, that the procedure can never conclusively prove that null hypothesis is true. So the question then comes that why do you accept the null hypothesis? What we are trying to find out is that there is not enough or sufficient evidence to reject it. So we can't prove it, but we can't reject it. Because we can't reject it, therefore we accept it. This is how we decide about the acceptance of null hypothesis. That because there's not enough evidence and hence we accept. It is something like in a court of law, a criminal is assumed to be innocent until he is proved guilty. So as long as he is not proved guilty, he is let off. There is no need to prove that whether he is innocent or not. Whether there is enough evidence to prove that he is guilty. As long as that evidence to prove guilty is not enough to say beyond certain probability, there has to be reasonable evidence against him. Then only he is considered to be a criminal. Otherwise, he will be let off. He will be considered to be innocent person. Hypothesis testings and significance level, these two go together. So significance level, now we are going to discuss, they go actually together. You will see that what is significance level? The probability of getting the evidence supplied by the sample mean when null hypothesis is true is called the significance level. How to find out significance level? The significance level is found out by considering the sampling distribution of means. And we know, we have already learned previously that the distribution of sample means will always follow normal distribution, irrespective of the distribution of the population. That was discussed previously. That means we will say, statistically we will write mu x bar is equal to mu 0. That is, the mean of sample mean is going to be the population mean if H0 is true, and standard deviation of sample mean is sigma by root n. This is also we have already learned earlier that how the standard deviation of sample means is related to standard deviation of populations, and this is also we call it standard error. So the next, the diagram is shown that the distribution of x bar, we already have learned, follows a beautiful normal distribution always. And mu x bar is mu 0, where the peak appears. Now, if we find out that the mean of a sample that we have chosen has a value x0 bar, or this 0, or you can say O means observed, is here, then the difference between these two, that is mu x bar and x0 bar, this difference, the more is the difference, the greater will be the doubt about the truth of null hypothesis. The larger this difference, the more will be the doubt. Now this difference is measured in which scale? These differences we measure by a scale you will come to know in Z scale, that is standard normal variable. Now the significance level alpha is the probability of getting a sample average as great as or greater than x bar 0. that what is the probability that you will get a sample average beyond x bar 0, that is here or here or here or here or here or here or here, this side. So the area of this part of the curve beyond x bar 0, if it is alpha, that will be the level of significance. So that is the probability that an observed sample mean may fall on x bar 0 or beyond. This probability is basically the area of the small part of this curve. And this area is alpha, and we call this probability as the significance level. If this is 5%, we call it level of significance is 5% or 0.05. Now we see here, as I said, how to find out the value of alpha, or first we calculate Z. This difference we have to calculate in terms of Z scale, as I said. So what is the value of Z? This is what you have learned earlier. The Z value at x bar 0 is x bar minus mu by sigma by root n. And I know what is the value of Z. Now alpha can be found out from the Z table. We can find out Z alpha from Z table, from the Z standard normal distribution table for a certain value of, if I put this value of Z from the table, I can then find out what is the value of alpha. So we have to consult the Z table for this. And if alpha is less than 1%, then null hypothesis can be rejected. Otherwise, we'll accept null hypothesis. So that value of alpha is chosen by us. If it is less than 1%, that means suppose it is 1% means 0.01. If it is less than 0.01, suppose it is 0.00, 0.0005. That means it is too far from this mean. That's why the area is too less. So this in a way indicates how far the observed sample mean is from the population mean. If it is too far, chances are bright that it belongs to the other populations. And that's why we reject the null hypothesis, which says that there is no change in the population mean because of changing the process, or could be changing a raw material, or whatever it is. Now comes two interesting points. One is one-tail test and another one is two-tail test. What does it mean? We'll start with first one-tail test. See, the normal distribution curve, or standard normal distribution curve, it has two tails, on the right hand side and on the left hand side. On the right hand side it goes towards infinity, on the left hand side also it goes towards infinity. And we say this n part, 2 part, we call it tail. So in the one-tail test, we want to know whether after modifying a process, the sample mean gives enough evidence to indicate either an increase or decrease depending upon the situations. That we are interested to know that either there is an increase or there is a decrease. And in two-tailed test, we will be interested to know whether a change in the process has made any differences in mean or not. That we want to include both increase or decrease. Both are included in two-tailed test. That whether there is a change has happened or not. In other case, in one-tailed test, it will be whether certain parameter has really increased, or we can say whether that parameter has decreased. So there is a difference between these two, one-tailed test and two-tailed test. So as we take up an example, it will be more clear. Example of, we start with an one-tailed test. So weight of finished garment, the same example we start. From previous experience is known to us what is the mean value and this is the standard deviation value. This is based on past experience, so or on the past data that we have in a particular industry, let us say. After process modifications, it came out to be 263 gram and number of samples 40. Now, in a one-tailed test, you are interested to know whether we'll be asking only one questions. In null hypothesis says there is no change. So mu is equal to 260. Though sample mean came to be 263. And what alternative hypothesis we are writing here? That mu is more than 260. That is, after the process has been changed, now the population mean is no more 260. It has increased, and a reflection of that we observe in the sample mean, which is 263 gram now. So we are interested to know. So alternative hypothesis we are writing mu is greater than 260. We see the diagram on the right hand side. So earlier the process mean is here, 260 gram is the weight. The sample mean we have found out to be x bar 0, which is 263 gram now, which is somewhere here. So we have to calculate first Z value. What is the corresponding Z here? This is what we need to know. So you have already learned about the way to calculate Z. Very simple formula: x bar minus mu by sigma by root over n. This is x. So you just substitute the values here and get a figure of Z, which is 2.37. Okay. So if this is the value that we get, now we need to find out what is the value of alpha when Z is 2.37. And for that we need to consult this Z table. Z tables were shown to you earlier. So you must, whenever you are listening this lecture, you must keep the tables ready in front of you and try to find out whether these values are correct or not, or how to read the Z values or alpha values, whatever is required. Here the Z values are given. We need to know what is the corresponding alpha value. So alpha is found to be this. Hence, there is a very low probability. The alpha is very, very low here. That means this distance is too large. The difference is too large. So hence, there is a very low probability of sample average to be as big as 263 if null hypothesis is true. So decision is null hypothesis is not true. So null hypothesis is to be rejected. So this kind of situation will always occur in an industry. There many a times we changes the process. We can change the, let us say, the process of spinning a yarn or process of changing the, let us say, finishing treatment that is given to a fabric, or weight reduction techniques which are there used for different types of fabrics during the fabric processing, and that is a possibility of weight reduction or weight gain, whatever it is, because fabric may shrink and the weight might increase also. So all sort of possibilities are there where count can change because of change of process, the strength can change, any parameter of the fiber, yarn, fabric can change, and we'll be interested to know what was earlier and what is now. Are there enough evidence to say that there is a change in the value of the parameter which is of concern to us? And in such situation, we need to carry out this kind of test. So test is very simple. Obviously, one has to do the experimentation to find out the values. What is standard deviation value and what is the value of mean by taking a sample. It is also very important that when you choose the samples, that we must choose the samples in a random manner. It is not that we should be biased in choosing the samples. That may lead to also wrong decisions. So the sampling techniques is, we have not yet discussed that point. So sometimes we'll discuss that how do I choose the samples so that the sample selection process is not biased. You have to avoid that. So this is one example of one tail test. So we're only interested to know about this, whether mu is greater than 260. If I got a value less than 260, suppose I got a value 256, then we could have written H1 as mu equal to less than 260 and carried out the test in exactly similar fashion. In that case, X0 would have been this side, because the sample mean now is less than 260. So the test procedure or solution procedure is exactly same. The values will differ now. There's another example which is there. Now read the example first. A tire manufacturing company claims that the average lifetime of certain tire, this is automobile tire, is at least 28,000 kilometers. This is a manufacturing company is claiming. Some manufacturing company, you know that tire manufacturing companies which are there in India. To check the claim, a transporting firm, they have many trucks, let us say. They may be having 500, 1,000 trucks running in the whole country. They want to decide, they decided to use 40 tires on trucks, and the lifetime of these tires was noted. So the sample was 40. The average lifetime was found to be 27,463 kilometers with standard deviation 1,348 kilometers. And we want to check whether this claim is correct or not. Whether whatever is being claimed by the manufacturer, this claim, we want to know whether the claim is justified. Is it really 28,000 kilometers? Because there is a commercial consideration. No, that if I am I represent the tire manufacturing company, sorry, the transporting company, then I know whether to accept this claim by the manufacturing company or not. Otherwise, I lose money by buying so many tires which may not give me 28,000 kilometers actually. In that case, it will be loss for the company. So company management has to make a very carefully. They have to take a decision. So our null hypothesis is H0, because what they are writing, at least 28,000 kilometers. That means H0 is mu greater than equal to 28,000 kilometers. And alternative hypothesis in this case, mu is less than 28,000 kilometers. So this is how we write the null hypothesis and alternative hypothesis. So why it is greater than equal to? Because this word is used, at least. And it could be more than this also. So therefore we write greater than equal to 28,000 kilometers. So now, if we go for the solution, the process steps are same, we find out Z. So Z, you know the formula, just substitute the values. This is the mean of the sample of 40 tires. This is the original value being claimed by the manufacturer, and we find out this way, and we get a figure minus 2.55. This is the calculated value of Z. And in this case, see, for normal distribution of the sample means, we always following normal distributions. So this is the distribution of Z, which is also normal, because Z is a normal distribution with mean 0 and standard deviation 1. And here is the value of the Z that we calculate. If we say at the level 0.01, the value of Z is 2.32. That means there is, from the table, this value has been taken. For a given value of alpha, at the level of 1% significant level, we want to check whether this claim is correct or not. So, if the level of significance is given, it should be written here, level of significance is 1%, then at 1%, what is the value of Z? This value, we need to consult the Z table, and we get a figure 2.32, which is here. Now, the calculated value of Z is coming more than this or less than this, not more. This is somewhere here, which is minus 2.55. So this is minus 2.55. So this is even far away from here. This is here. Therefore, what we should say, null hypothesis is to be rejected. That is our conclusion. So we'll say the claim is not correct. And we reject the claim. So we decide not to buy, or even if we think that we should buy it, then we can negotiate the price now. And we can ask for discount. Then no, with this, our test shows that it cannot be so much. So therefore, our decision is not to buy it, or if we want to give it to us, then price has to be negotiated further. So that kind of decision the management then can take. So there is a statistical analysis that we do, and based on that analysis, the management takes a objective decision. Now we'll go for two-tailed test. Let us test a yarn with linear density given 32 text, that is a nominal linear density, and sample testers are 192. Sample mean is found to be this much, 31.13 text, and standard deviation is 0.79 text. Any sample mean less than 31.13, we are concerned about. Now question is there enough evidence to suggest that the population mean is different from the nominal? So nominal linear density means what? That when I set a machine, about ring spinning machine or rotor spinning machine, I hope you are all familiar with the machines which are used to produce yarns for a particular count. So we set a machine to produce a particular count, and we call it nominal count of yarn. So the machine has been set. So the mechanical parameters of the machines and the linear density of the input material, based on that, we have decided that the machine has been set to produce 32 texts. Now we want to check that whatever I am producing, is it really 32 texts or not? And for that, what we are doing? We have taken a sample which is 192 number. The mean is 31.13. And standard deviation is also this, 0.79 texts. Is there enough evidence to suggest that the population mean is different from the nominal? In this case, we are concerned about the deviations in both directions, because we neither want to produce a coarser yarn nor want to produce a finer yarn. Both way we may lose. So a sample mean less than 31.13 would deviate further and shows stronger evidence against H0. Now here, the distribution of sample means are shown. So nominal mean is mu equal to 32. It is the nominal, and the sample means distribution is given here, and the x bar 0 is 31.13. Similarly, if the sample means happens to be 32.87, like here, greater than 32.87, will also deviate like the left hand tail. Any sample mean less than 31.13 would deviate further and show stronger evidence against H0. Significance level is the probability of getting sample mean that differs from the nominal by as much as or more than x bar 0 does. So in this case, how do I write the null hypothesis and alternative hypothesis? Null hypothesis will be mu is equal to mu 0 or mu 0 is 32. That is what is the nominal mean the machine is supposed to produce. An alternative hypothesis is mu is not equal to mu 0. So what we do? We calculate the z value. When we get an x bar value 31.13. After testing 192 samples, suppose we get a figure 31.13, which is less than 32. So we find out what is the value of z, which is minus 15.3. And alpha for z minus 15.3 will be very, very low. So the value of z in this case is very, very large. It is beyond, you can say 3 sigma, 4 sigma, 5 sigma, 6 sigma. It is too far from the, in terms of z scale, it is too far from the population mean. And therefore, possibility of getting such a large value of sample mean is not large value, it should be low value. Sample means is too low. This value is not large, this value is low. The decision is null hypothesis is not true, because the z value is very, very large. And even for the value of z, which is minus 15.3, the corresponding alpha value you cannot find out it on the table also. In the z table, for z of 15.3, the corresponding alpha will not be available in the tables, because such kind of z means alpha is too low. It is so high that we accept that mean is different from this. The whatever we are producing now is definitely different from the nominal mean. The diagrams are now shown here. So actually we are considering two cases. One is when the observed mean is this. Other case also we can consider when it is large, greater than b equal to the nominal mean 32. Criteria for rejection of hypothesis. Let z alpha be the value of z for which area under the standard normal curve to its right is alpha. So that is what we call z alpha. So the value of z for which the area under the standard normal curve to its right is alpha. And critical region is the sets of values of z for which we reject null hypothesis. Now solution steps, as we have already discussed, calculate z following this formula, compare z with z alpha. The diagram also similarly shown. For a given alpha, we find out what is the z alpha, and then we calculate this z. So that is z which is calculated. So we compare the z and z alpha. When we compare z with z alpha, what are the possibilities that we can have? Z alpha could be less than minus Z alpha. Z could be less than greater than Z alpha, or Z is less than minus Z alpha 2 or greater than plus Z alpha by 2. There are three different possibilities which are there. In this case, the alternative hypotheses are shown here. That is, alternative hypothesis mu equal to mu 0 if it is. Then the moment Z value, calculated Z, is less than minus Z alpha, we reject in our hypothesis. If the alternative hypothesis we propose mu is greater than mu 0, in that case, if Z is greater than plus Z alpha, we reject the hypothesis. That means in that case, the Z value will come on the positive side. In the previous case, Z value will come on the minus side. Here, mu equal to mu 0, but in terms of Z, this is equal to 0. And this is the positive side of Z. This is the positive side of Z, and this is the negative side values of Z. This side is positive Z, and this side is negative Z, starting from this point. Here, Z is 0. So, these are the alternative hypotheses, and corresponding, if Z is greater than this or Z is less than minus Z alpha, we reject. Or when the alternative hypothesis mu is not equal to mu 0, in that case Z will be minus Z alpha by 2 or Z will be greater than Z alpha by 2 and will be for alpha, for two different values of alpha, the critical values of the criteria are when alpha is 0.05, critical values will be, Z value will be minus 1645 or plus 1645. This is available from the table. One can consult the table, Z table, go for alpha 0.05 and you see the values. What is the Z value? For one-sided test, it will be 1.645 plus or minus. For two-sided test, it will be 1.96 plus or minus. And if I choose alpha value to be 0.01, that means 1% level of significance. The critical value of the criteria are 2.32, minus 2.32 or plus 2.32 for one-sided test, and for two-sided test minus 2.575 or plus 2.575. I think there is a problem here. We can check on the table and correct it. So these are how we can know critical regions for mu equal to mu 0 and for normal population when sigma is known. These are stated. So what is stated here is null hypothesis. What is stated here are alternative hypothesis. Assuming in this case the population is normal and population standard deviation is known, because then only sigma by root n we have to calculate. So if sigma is not known, then we will not be able to calculate. That means population standard deviation is known. Now we can also have situations when the population standard deviation is not known. So critical regions when sample size is large but sigma is unknown. What it is written here? Substitute S for sigma. S is sample standard deviations. So in this case, we can use the sample standard deviation as a substitute of population standard deviations, provided n is large and population is also normal. These are the two assumptions. N is large is not an assumption, but population is normal is an assumption. N large means n has to be greater than equal to 30. That is considered to be a large sample size. When n goes 30 and above. When n is less than that, it is considered to be not large. N value 10, 15, 18, 12, 6, 8, considered to be n is small size. So in that case, this situation is will go basically exactly the same steps are followed, or same logic is there, exactly same logic. Critical region is going to be exactly same. So if you compare this slide with the previous one, there is no change. We have to calculate Z, but the formula of Z now S is going to come. In the previous slide, you will find S was replaced by sigma. So now this will be S. And by using S, we will be able to calculate the standard normal variable Z. The other situation may come when sample size is small. We can also face this, and standard deviation is unknown. In that case, what we'll calculate is no more Z. Now you have to go for T statistics, which also you have learned that you have to calculate the value of T, and the formula of T is given here, and it is exactly similar like formula of Z. So very easy to remember. The formula structure of the formula are more or less similar. So instead of writing Z, we should write T because the sample size is small. Maybe the n value of n may be 12. So in this case, we'll calculate T, and now my critical for all this hypothesis as we write, we will now go for the T table. Instead of Z table, now we'll look at the T table and find out what is T alpha for a given value of alpha. Alpha may be, as I have shown earlier, alpha could be 0.01 or alpha could be 0.05. Alpha is the level of significance. That is the area under the curve for a given value of T, beyond which the area is going to be alpha. So this is so exactly similar in nature, or whatever you have written earlier. The Z has been replaced by small t here, and these are the critical regions, and we conclude based on this. Compare the calculated value T with T alpha, and either we have this situations or this situations or this situations. So in all these three cases, depending upon what are the alternative hypotheses, our conclusion is be reject null hypothesis. So rejection conclusion based on these three, whether T is less than T alpha, whether T is greater than T alpha, or whether T is greater than T alpha by 2. All depends upon what is the alternative hypothesis for in a given situations. So based on this, we do our own conclusions. So now we can go for another example related to calculation of T. The specification of tape says that the breaking strength should be 180 kg force. If 5 pieces of tapes are selected from different rolls, have a mean breaking strength of 169.5 kg force with standard deviation 5.7, is there enough evidence to accept or reject the consignment? So the specification says that it should be at least 180 kg force. That should be the strength. And to check it, 5 pieces of tapes are selected from different rolls and the breaking strength is 169.5, which is less than what is being claimed or what is the specification beyond. And there is a standard deviation of 5.7 kg force. Is there enough evidence to accept or reject the consignment? So solution procedure, null hypothesis, mu is equal to 180. That even though sample data says 169.5, and therefore you will be tempted to comment that the tapes are weak, whatever tapes are coming to us, they are weak, which is not, which may or may not be true. So let us, therefore, in this case, the null hypothesis is mu equal to 180. Alternative hypothesis is mu is less than 180 because the sample mean we have found to be less than 180 kg force. So alternative hypothesis mu is less than 180. So in this case, we cannot calculate Z because we are testing very few samples, not 30. And hence Z value cannot be, Z table or Z statistics we should not calculate. What we calculate is T, and we find out what is the calculated value of T from the existing data. So T value is going to be this. This would be S. It is going to be minus 4.119. And you see the T distribution table is shown here, not the table, the distribution curve is shown here, and T distribution curve is very similar to Z distribution curves. Now the value of T calculated is here. It is minus 4.12. From the table, for 1% level of significance, which is means 0.01, we calculate what is the value of T. But if you consult the T table, you will always find there is a degree of freedom column also is there. So you have to know what is the degree of freedom in this case. Without degree of freedom, we will not be able to find out T value. So in this case, degree of freedom dF is 5 minus 1, that is 4. And for T value for degree of freedom 4 and alpha 0.01, the value of T is, you can see from the table, minus 3.75, which will be somewhere here. So calculated T is less than 3 minus 3.75. See, calculated value of T is minus 4.12, and the T that you get for alpha, that means if alpha is here, which is alpha, this is this whole area from here to there, the T value here is how much? Minus 3.75. But the calculated value T is somewhere here. So it is far away from the mean, and therefore the conclusion will be null hypothesis is rejected. Null hypothesis is to be rejected in this case. That means the consignment which is coming to us is not of right quality. The tapes are basically weaker than what is being claimed, or whatever is the specifications that we have given to the manufacturer. Okay.